Hi guys, today we're going to look at carrying out a geographical investigation. So the first thing I need you to do is, as we always do, title, date, have a go at that do now, that starter. So we've done a few lessons on permeable and impermeable surfaces already in our rivers topic. So I'm sure everyone got this right. So the area most likely to flood is this area here, the urbanised area, these narrow streets, these small storm drains, as opposed to this grassy area here, which will be able to hold on a lot more water. Okay, let's go on to the main bulk of the lesson, and this is around geographical inquiry. First stage is introduction and planning. So we're going to do a bit of that today. We're going to do all of that today, actually, the inquiry question, the hypothesis, the predictions. You're going to work through this. What I'd like you to do, as always, where you see the orange, this is something you need to copy down. As I'm not there, I'm not in the class with you, we're not going to do so much interaction. It's more me feeding you information, but doing it in a way that making sure that you understand what you need to do to answer questions around this and really understand what it is to go out and do some field work. First stage, introduction and planning. Our second stage will be the methods that we would use to collect our data. The third stage is our data presentation. So once we've got the data, we come back to the classroom, we come back to the university, we present our data. How do we present it so it's more readable and we can therefore analyse that data? Once we've analysed that data, we can come to some conclusions. And then the last stage is to evaluate not just our conclusions, but evaluate the fieldwork that we have carried out ourselves. Area orange. So, introduction and planning. Please write that down as a subtitle. So, this first stage is about deciding what you're going to study in the area of geography that you're wanting to study. So, in this case, we're going to have a look at urban areas and different surface areas in the urban area and infiltration rates. So the rate at which a water can absorb, infiltrate into a surface area. So write this down. Our area of study is infiltration rates on different surfaces. Now, just as a reminder for infiltration, we've talked about infiltration before, but I know that's a bit of a tricky word sometimes to remember. So write down the definition. Infiltration rate is the speed or rate at which water soaks into a surface or into the ground. So I'll give you a few more seconds to write those sections down. So here's a good question. Why is it important for us to understand infiltration rates? Have a think about that just for a few seconds, and I'll go through some of the broader ideas which we'll look at in a bit of detail in the next few minutes. Understanding infiltration rates helps us urban planners and geographers to manage flood risk. Which areas are more likely to flood, which areas can hold and manage water. Also, understanding infiltration rates is really important to farmers so they can understand and support agriculture and agricultural techniques. The planning of sustainable cities, especially with the ever-changing climate that we have, planning sustainable cities and finally conserving groundwater. So that's a lot to take in, which we'll look at in a bit of detail in a moment. Okay, So geographical investigation, this is all about asking questions and then trying to find the answers for them. So make some examples of that. How does traffic volume affect air quality? That's a really good fieldwork question and activity to get involved in and carry out, measuring traffic volume. Noise pollution is another good urban fieldwork that you could do, and we could look at different parts of the city, perhaps Bromley, and then the centre of Bromley or the outskirts, and see how the noise pollution varies. Of course, for us, we're doing rivers and we're doing water and the hydrological cycle and all those areas around that. So we're going to look at infiltration. So our inquiry question will be this. How does the type of urban surface affect infiltration rates? So again, just write down, we've got our area of inquiry. Now we want a very, very clear inquiry question. We want to answer that question. So let's look again at areas within urban areas and beyond, while we would look at infiltration rates. So this is an area where we can see this very large surface runoff. It's heavy rain, large surface runoff, so the area that all this concrete here, the water cannot infiltrate. So having an idea of the types of surfaces that can hold water, where the water runs off or where it infiltrates, can help us design sustainable cities where we don't get flooding. Second good reason is around farming. So this is about soil health. So infiltration affects plant growth, obviously healthy soils, allowing water into the soil but allowing nutrients to reach roots. So we've got flood prevention, soil health, another good reason to investigate infiltration rates. Wider urban planning, this is a really lovely picture of some thoughts being put into the water holding capacity of a town here. So as we might imagine, water can't infiltrate here, but it certainly can be held here, therefore slows the amount of water that goes into the storm drains and lessens the likelihood of flooding in this area here. I'll give you another urban planning picture as well. It's a really good one. You can probably guess already from things that we've already talked about that some of these areas here have obviously higher water capacity rates. And next one, and the last one, is water conservation. This is around groundwater. We need to know, as it rains, we need to know that our groundwater is being recharged, because in and around we extract water to feed our ever-growing cities. Okay, so there's a table for you to complete. So I'd like you to have a read through these, identify what the key reasons for understanding and investigating infiltration rates. And you can pause the video for 5 minutes so you guys can do that. So I hope that's all glued into your books. Let's see if we got that right. Just make any adjustments now if you need to. I'm going to show you a short clip now on understanding the importance of fieldwork, just to build on what we just had a look at.
Fieldwork brings geography to life and allows us to analyze our surroundings in real detail. It enables us to look closely at things at a local level. If we visit a location, we can collect information that is simply not available otherwise. What's more, if you're on a field trip, you can learn and apply certain skills such as data collection and processing, making questionnaires and maps, observing, interviewing, and using statistical techniques to analyze your results and prove your hypotheses. Also, it's hugely enjoyable.
Or, to put it a slightly different way, Geography field trips are class. Nothing beats getting away and losing yourself in nature with your friends and classmates. Okay, it might feel a bit weird at first, climbing up mountains, wading into rivers and scrabbling around on beaches in your practical but not very flattering outdoor gear. But once you're there, you get so into it. This is what geography's all about. Getting outside into our surroundings and learning firsthand. Textbooks can't teach everything. Fieldwork is crucial. Measuring, collecting information, talking to people, using equipment, understanding maps. It all starts to make sense when you actually apply the skills and knowledge you learnt in class. You think differently about places once you examine them in detail and begin to see that everything is connected. People, cultures, wildlife, nature, weather, everything. It blows your mind. Even better, it is such a laugh. You might not realise it at the time, but field trips change the way you see things and people. You really remember them. I think it's because you're out there doing things you never expected and getting up close and personal with nature. Gotta love field trips.
Okay, so we're going to have a look at the next stage of our geographical inquiry, which is our methods and data collection. Now, in terms of looking at urban surfaces, we could also consider tarmac and concrete, but measuring infiltration rates on those surfaces is quite tricky because this doesn't infiltrate at all and it just seeps out the side. So we're going to choose 4 virtual surfaces that we could look at if we went out into an urban area. So these are our sites. The first one is grass. The second one is a flower bed in the urban area. The third is a gravel driveway, and the fourth is our block paving. Okay, so now we've identified some sites, we need a hypothesis and we need a prediction. This is part of our planning as to what we're going to research. What do we think we will find?
We are going to look at the 2 words prediction and hypothesis. It's important to know the difference between them.
A hypothesis is an idea about how something works that can be tested using experiments.
A prediction is a statement of what we think will happen if the hypothesis is correct.
So you use your hypothesis to make a prediction.
I reckon where there's more oxygen, it will last the longest. I'm thinking maybe 40 seconds.
Here, my hypothesis is that the more air and oxygen candles have, the longer they stay alight.
So, if my hypothesis is correct, then my prediction is that candles in larger measuring beakers will burn for longer.
As the volume of air increases, then the time the candle takes to go out also increases. Our graph shows us the pattern in our results.
The bigger the measuring beaker, the more air, and the longer the candle burnt.
So, we have seen an experiment looking at how long a candle burns under different beakers.
We have formed a hypothesis, and then we have tested it, looking at the difference between the meaning of the word hypothesis and the word prediction.
Okay, so let's look at some example hypotheses and predictions. Here's an inquiry question. What is the impact of sleep on a teenager? So a hypothesis might be teenagers who get more sleep will be more productive. The prediction might be if a teenager gets 8 hours or more of sleep, then they will be more productive the next day. So our hypothesis and our prediction. Let's look at another example. Is sunlight necessary for seeds to grow? Our hypothesis could be sunlight is necessary for seeds to grow. Our prediction, therefore, once we've carried out our research, seeds grown in bags wrapped in aluminium foil will make shorter plants than seeds grown in bags not wrapped in foil, as they can access sunlight. So our hypothesis and prediction. Now, for us, we are looking at infiltration rates, the rate of which the water will seep into infiltrate these different surfaces. So what I'd like you to do is write down your hypothesis and your prediction. Pause the video now. You'll take about 7 to 8 minutes to do this. So your hypothesis is your own hypothesis. It's not wrong or right, it's yours. But you may have written something like this. So we're going to investigate infiltration rates in these urban areas and on these 4 different surfaces. So different urban surfaces will have different infiltration rates. That's the hypothesis. The prediction, directly relating to where we're going to do our site surveys and infiltration rate measures. Infiltration will be fastest on sites 1 and 2. Site 4 will have the next fastest, and site 5, the slowest infiltration rate. Okay, some equipment that we need. So pause the video just for 2 minutes so you can write this list down. You can write it down as a list or equipment we need and just branches off it to help you remember. So equipment we need: stopwatch, infiltration tube, 500 milliliter water per site, a data record sheet, and a stopwatch. Now let's have a look at how this might be carried out in the field.
Hi guys, you can hear me, it's a little windy out here, a little windy, a little bit cold, but all weathers are great weathers when you're a geographer to be outside and especially to do investigative research and field work. So we're going to do a little bit of field work today on infiltration rates. There are 4 surfaces in the lesson that you're going to examine. I'm just going to show you one, but the technique is obviously the same for all 4 surfaces. Let's make sure we've got all the equipment first of all. Alright, our data sheet. We need to obviously record all the data on a sheet. A pencil is an ideal thing as well, just in case of rain. We need an infiltration tube. Let me get it closer. So inside this tube, there are 2 rings. So just a normal tin of tomatoes. Other brands and condiments are available. So we've got a ring at the top and a ring at the bottom. I just used a simple pen to draw that, and that's given us our tube, infiltration tube. Okay, we need to put it on our surface, and we need a hammer to bang it into the bottom line. So we do that. We use a piece of cardboard or a piece of wood just to make sure there's no damage we can. Good stuff. Now we're going to fill 500 millilitres of water into the infiltration tube. Get our stopwatch ready. Fill it just above the line. And then we wait for it to get to the line. Stop stopwatch. Gone. Pretty good. And we'll record that on our sheets. Now on the sheet here, I've got 3 different measurements that you can take and then take the average. That's it, recording infiltration rates, in this case, on grass surface.
Okay, so if you can grab your table now, glue this into your book, write down the top title, so the data presentations is where we are in the stage. Write down this explanation here to help you remember. You've got this table completed as if we'd gone out there and done the measurements. So all you need to do now is the calculation, giving you the infiltration rate. So it's 500 milliliters divided by the seconds, and that will give you millilitres per second. So pause the video now and complete this table. That was easy. Okay, so your table should look a little bit like that. All right, now next stage is to present our data. One of the best ways to present our data is in the form of a graph. So you have a graph like this, completed with one measurement from the grass. So what I'd like you to do is complete the graph. It should look at something like that when you're finished. So pause the video and add the infiltration rates for each of the sites that we measured. And there we have it. So let's look at our next stage. We've done an introduction and planning. We've looked at the area of research we want to look at. We've looked at our inquiry question. We've come up with a hypothesis, a prediction. We've gone into the field. We've taken the measurements, recorded in our data sheet. We've presented our data. Now we want to do some analysis. What is that data telling us? So write this header up, data analysis, and I'd like you to explain what you can see here. So the data shows that, and explain in your own words. Okay, so you can pause the video. This will take you about 10 minutes. Okay, so we're now moving on to our conclusions. So in your conclusions, you want to talk about your hypothesis. So was your hypothesis correct and your predictions correct, partly correct, fully correct? I have shown that in summary. So a few words to help you there. So what has this bit of research shown you about infiltration rates, about surfaces in urban areas? And our last stage is evaluation. The evaluation is, what else could we do to improve this research? I'd like you to spend a few moments writing down, what could you do to improve this type of research? Could you do more sites, services? Is there anything else that you could do? Were there any problems or any issues around the infiltration rates method that we used? And after you've done that, you're done.